I'm just going to give a very quick basic overview as to how the patch Maximus is functioning, and also how the sketch and processing is creating the visuals. Any further details will be given in the report. So this is the general interface for Maximus P. This will control the sound and also what you'll be seeing, because it will pass it on to via OSC to processing. There's three different modes that you can select: live data, user mode, and demo mode. Live data is actually dealing with the current information that will be coming from the weather station that's located outside by Bluetooth. User mode gives anyone the capability to play around with any of the intensities or the scales or the keys, just to get a feel, or what it can sound or look like in certain situations. And demo mode, which actually replays all live data that was recorded up here using the record function into a call object. I'm just going to jump right into the code right now. So depending on which mode is selected, will open up a section or a gate. So that's dealing with live data first. We'll open this first section of this gate, which will bang a metro, which has been passed down through, and bang onto the serial object right here. What the serial object is the port where the Bluetooth will be sending in the 5 pieces of meteorological data. These 5 pieces of meteorological data are going to be represented by ASCII forms of L, P, R, T, and W, and then be routed. Once they are routed, they're converted back into integers, so they're easily understandable by the likes of myself. So these raw data are then going to come in and get scaled and intensity rated from 1 to 10. Also, the raw data is going to be sent off for recording. This can be initiated or can be turned off. It doesn't have to be turned on. So once these are all given intensity rating 1 to 10, they're going to be capable of sending on to processing, which is down here via OSC. Now, the only ones that are being sent over as VR is light, pressure, temperature, and wind. They'll be 1 to 10. Rain is a bit different. The reason rain is different is because that comes in at an intensity rating 1 to 10, and it sets the speed of how much it will play these short staccato high frequency notes. But in turn, as each note is played, it's going to send a random number 0 to 11 to processing instead. That way, it's going to initiate one of the 12 shapes, highlight them, and they will change accordingly based on what number was sent. I want to explain the averaging system, which inverts some of the intensities. Well, the reason for doing this is because obviously some of them 1 to 10s, 1 will represent bad, because let's say 1 is good for rain because 1 is low rain, but 1 is bad for temperature because 1 it would be cold. So I wanted to invert everything, so 1 is bad and 10 is good. The reason that way I can do that is because then I can give a general average as to what the current weather state is. So if the general average was, what's that, 7 or up maybe, yeah, that gives a pentatonic scale, which sounds good to the ear, and voice. In the flip side, yeah, for the chromatic scale, if it's low average rating, it's going to play in a chromatic scale. This has got to do with consonance and dissonance, the difference between something that sounds pleasant and something that sounds unpleasant to the human ear. These average ratings are what determines the sound of the synth. The synth has been played in here. As you can see, it's added synthesis, which has a number of different waves that are playing over each other, fading in and out. Also, there are two transient sounds which are made up of the sound. These are the rain and the wind. These are transient sounds because they're not always on. They're coming on and off depending on the intensity rating. So, dealing with demo mode, if it was to be thrown into demo mode, it plays on an old text file that was previously recorded by a weather station. How demo mode works is essentially the exact same as how live data works, only that the live data coming in has been turned off, and it's been switched with what is within this call object right here, which is uploaded by pressing upload a file, and you can select which file to upload, and it'll play through an old text file. If you want the readings to sound, the output to be accurate and sound and look what it's supposed to be like, well, you have to ensure that it's actually previously recorded data, because it's 5 pieces of information. You can't just upload any text file and expect it to work the exact same. Scaling all works the same, as I said. It's just replacing the incoming data as live one with what was previously recorded at a different point in time. There's obviously a lot more to this code explained, much more detail live, and much more detail on demo, and much more detail even in, I haven't touched off it properly, user mode. These will all be touched on in the written report. So I'm just going to quickly run through what the visuals are capable of doing. These are all based on what intensity rating is sent from max MSP and via OSC. Each of these OSC events are sent individually so they will not interfere with one another when they're updating. So these all come in here in the OSC event. So as you can see, each one has their own type tag. So once they get their intensity rating 1 to 10, or for most cases 1 to 10, these OSC events we'll be expecting, these will get passed into, let's say, variables which are within the according functions. So the functions, depending on which number 1 to 10 is selected, is expecting a case. So that will actually insert the new variable figures that will in turn decide what each attribute will look like. So, oh, and I must point out these can ramp between one another also. They don't jump between values in cases if there was a change in state. These smoothly ramp between each state, let's say, once they are called upon in the update function, which is also within here, the polygon class. So as you can see, it's ramping between them. These shapes are all fundamentally generated or created anyway, the basis of them in an array list in the setup, which is here. So the array list was declared up in the glory variables, and then I'm saying, hey, look, I want to make 12 shapes. This says you make hard coding the 12 attributes for each of these shapes, and I can just access it easily and fill them in 12 times over using for loops and accessing different points of the array list. I must point out that the size and the location of each of these 12 shapes is completely dependent on the screen width and height that is being used, whether it be a Mac laptop or Windows screen, a large iMac. I've tried to make it relative for it to calculate always be in the same position relative to the size of the screen. The polygon class essentially deals with all these details that are coming in: color, size, the ellipse opacity, the speed of rotation. Um, all these details are going to have a choice of two. They're either going to be off, static state, which is going to be sent from max P if we lost connection, or it's going to be on, which is going to be movement, it's going to be color, it's going to show that they're hey, we got connection. What color should I be? What size should I be? Max P will let it know all of that based on incoming data from Arduino or replaying demo. So as you can see, these are all just the details of what each thing, shape, color should be like. All these variables that you're seeing, like temp color 1, temp color 2, there's loads and loads of those, which are all generated by these functions, which again, I must remind you that is sent in via OSC from Maximus P. This here is particularly interesting. It's a for loop, which is, let's say, it's looking from the point of view of each particular shape. So there's 6 sides of the shape, so that means I'm going to say, hey, draw 6 ellipses relative to the size of each of those shapes, and that's actually made a cloud coverage. This is all within the pop matrix here because I wanted it to be the point of view of each of the edges. Again, it says you hard coding each individual shape in each individual location. It just follows that point, then translated automatically all the time. That's pretty much the complete absolute basic of the visuals and the absolute basic of Max MSP. Any further details are going to be commented in here into the actual sketches and commenting into the Max MSP patch, and then further detail in the report.